This video I'm going to experiment with sodium stearate to make a antiperspirant deodorant. This is a collaboration with Rebecca Cosmetics. She's going to be doing a formula of her own, and this one I'm going to be doing an antiperspirant. And I'm also going to talk about the chemistry of sodium stearate and why we can't just add it to a formulation, heat it up, and expect good results. This is actually my fourth test for this formulation, and after a lot of thinking and doing a lot of research, I think this formula is going to turn out, but just like anything, I'm gonna test it out and see how it works. So the full formulation and everything will be on my blog. For this video, I'm just going to talk about the process and the ingredients that I'm using. Just because a blog format is way easier to talk about substitutions and method, you'll be able to see through the video. So obviously I talked about sodium stearate, so we need sodium stearate. This is a thickener. It's very common in deodorant formulas. It does have a high pH, and unfortunately you cannot adjust it, but this is going to be in an anhydrous formulation, so it's gonna be okay. So as a solvent, I'm using propylene glycol. Propanediol 1,3 would be a natural substitute for it, but we need some sort of glycol to dissolve the sodium stearate. And I've tried formulas with a little bit of water, and they just have not worked. So, and I made a formula that has worked before, but I only use propylene glycol as the solvent. So for the antiperspirant effect, I'm using aluminum chlorohydrate. The aluminum products are the only ones that can be used for antiperspirant, and antiperspirant actually can help stop the sweating or reduce the sweating, whereas deodorants just kind of cover up or they eliminate odors, which is very different. So yeah, I know there's a lot of misinformation about aluminum, and I will get into that into the blog post. But obviously, if you don't want to use it, you don't have to use it. But I'm using it in this formula to make an antiperspirant. And finally is the preservative. I'm choosing this one because the ethyl hexyl glycerin actually has some deodorant properties as well, and it can be in high heat as well. So yeah, let's get started with the formulation. So one of the issues that I was having is that I don't think when you have a very low input of water, it's very difficult to dissolve ionic compounds like this. So I did some research on this one. This one can be used in anhydrous products, so that's an important thing to know. But I tend to find with a lot of the products that I have, they clump up a lot. So what I'm going to do is, so under here is a glass prep cup, and I put this on the scale, and then I have a sieve here, and I'm going to make sure that the scale is 0. I'm basically going to run it through the sieve, and I'm not going to add this until the solution has fully dissolved. And that way that everything I know is even and a similar particle size, so that when I actually have to pour it, that it will be okay. So after I've weighed out the 8 grams, just going to run it through the sieve. I'm gonna spray this. Hopefully now you can really see, I mean, the difference between the two. A sieve can really help make powders even. Good news, I was able to get it dissolved, so I'll explain in the chemistry section of why this works. There's other beakers from failed attempts, and I'm trying to clean it, so that's why it's there. I do recommend investing in one of these hot gloves because it is very hot in there. So I have my station set up. I'm going to take it out, and then I need to add the aluminum chloride and the preservative, and then this formulation will be done. To protect my scale, I'm using a plastic cover for the scales. If you have one of those like $20 or $30 ones, they normally come with this as a protector, just because heat actually can affect your scale. Have to go quickly with this. We need 0.5 grams. So and that's going to have to do. So I'm going to stir this up. Turn that off for now. I'm going to add in the aluminum chloride. Yeah, I had a feeling about this. Really want to make sure it's smooth. And I found my culprit. It's the deodorant ingredient. Okay, so the first, the fourth formulation that I made earlier today was a complete fail, and what I figured out is that the aluminum chlorohydrate does not like anionic ingredients at all, which the sodium stearate is anionic. So that's why it was curdling right after I added it into the base. So I'm going to pivot a little bit. I know the base works because when I melted, everything was fine. It was just the addition, and my formula was quite basic. So I am going to try a deodorant ingredient. I'm going to try zinc granulate and see if that works. So it's not antiperspirant, so it will not prevent sweat, but it will help with odor. So I'm going to use it at the highest percentage because I know myself already that I will need to use it at the highest percentage. So I'm really keeping everything the same. I'm going to still make it as an anhydrous formulation, including no water. But I'm going to be including the zinc stearate, and the sodium stearate should be able to emulsify the 3% that I'm going to add of the zinc granulate. So let's get started. So I cleaned everything and disinfected everything, so I have all of that. I'm thinking what I'm going to do from the formulation process is I'm going to first I make sure that the sodium stearate is fully dissolved, and then I'm going to add the zinc stearate because it will be an emulsion. So I'm gonna kind of do those separately, and then just do it a hot process type of formulation. So next I'm gonna weigh out the zinc stearate. And I will adjust that. Okay, so I had to work quickly, so I wasn't able to get it on camera. But basically, I was able to melt the sodium stearate down, and then I wasn't able to show it because it was a very intense process. But I added the zinc granulate. All I have left to add is the preservative. So I'm just letting it cool down a little bit, and then I will package it.
So in this portion of the video, I wanted to talk about the science of sodium stearate and why we cannot just heat it up in some water and expect the product to work. And this is also the reason why I've had to do a lot of tests because I've had to kind of think this out and take a different approach. So sodium stearate is a result of a chemical reaction. So it starts with stearic acid. Stearic acid is a fatty acid. So fatty acid means it has a long chain with a carboxylic acid group on it. So I will actually draw it out. Oops. So it has an 18 carbon chain. This is what stearic acid looks like. So when we react it with a strong base such as sodium hydroxide, what sodium hydroxide does in water is it dissociates. So you have Na plus and OH minus. And the strong base will get the hydrogen. So to simplify this, I'm going to represent the long chain as R. So we have the C, OH, and then we have this O here, and it will have a negative charge. We'll have the sodium, the plus charge, and then we will have water. So this is an acid base reaction. Uh, hydroxide is the base. The H the H right here is acidic, and that goes based off of organic chemistry. I know this is already probably a lot of chemistry right now, but it's acidic, so then it creates a carboxylate ion. So this is actually then a soap. Now this is not the saponification reaction. This is just acid base, but because we have the negative charge and goes from it goes to a carboxylic ion. We this is the sodium stearate. So, so yeah, the sodium stearate. So now you have to understand um, more about this. So this is an ionic compound, and ionic compounds are salts, and they are a combination of a metal and a nonmetal. So um, obviously sodium is the metal, and then this all here is a nonmetal. And we have to understand with ionic compounds is they have a very high melting point. So you will not be able to melt sodium stearate. However, it does have some solubility in water because of the long chain length. It will not have very good solubility in water. So what you have to do is you have to use a solvent like glycerin or propylene glycol is a really common one. And sodium stearate is used in deodorants a lot. So the other thing is because of this, it can only be in a basic environment. If you put it in a very acidic environment, it will go back to the um, fatty acid, stearic acid. So you unfortunately cannot have it in an acidic condition. So